All right, so the last lesson of this unit, you know what that means? There is a test coming up. So this is kind of a strange lesson. It doesn't tie into math at a later point. It's just kind of one of those random things that I have to teach you. It's not hard, it's just a little weird. So keep an open mind. And at first, it's probably not going to make sense. So this is all about variation, and there's 5 different types of variation that we're going to talk about. So the first one is direct variation. You need to have this formula, that equation memorized. So direct variation is y equals k times x. And then something you should know is k is the constant of variation. So I don't know why they didn't use c for constant, they used k. It is what it is. Okay, so you need to know what direct variation is. Inverse variation is whenever it's k divided by x. And you need to know that one as well. Have both of those memorized for your quiz and your test. Just know direct is being multiplied and inverse is k divided by x. Okay, so direct and inverse is when it has 2 variables in the equation. Well, I should say actually 3. So it's the direct part is the k times x, and it has an inverse, which is the divided by y. So it's putting those 2 together. Okay, joint variation. This one's not very common, but you might see it on the homework. Joint variation is when you have k being multiplied by 2 variables. Okay, so now joint and inverse, they're putting the joint that we just had above there and the inverse one together. So it looks like on top, k times xy divided by another variable, they chose w. Okay, so like I said, the first 2 is really what you need to know for the test and quiz. So this kind of cut off weird, so if yours is weird on yours, go ahead and fix it. So this would be 3, 6, 4, and 8. That would be 2 and 8, and 3 and 11. So now for each function, determine whether y varies directly. So what does it mean for y to vary directly? Well, that would be direct variation. So y equals k times x. So determine if it does. If so, what is the constant of variation? So what is the k? And then what is the function rule? So if you're looking at this table, do you notice anything that's happening to the x's? Hopefully you are seeing, if not, that's okay, that they're being multiplied by 2. So 1 times 2 is 2, 3 times 2 is 6, 4 times 2 is 8. So it is constant. So is this direct variation? What would the equation look like for this? It would look like y equals 2x, 2 times x. Is it direct? Yes, it is. It is direct. So let's put that. And then the last thing it wanted you to find is what is k, the constant? K equals 2. And that's literally all you have to do for this problem. Okay. So on B, same directions. Do you see a pattern of what's happening? I see 1 times 4, 2 times 4, and not 3 times 4. So if it were just those first 2 lines, this would be direct variation. It's being multiplied by 4. But you have to look at every single line of your table, no matter how many they give you, to make sure it works throughout. Because even if one messes up, like this one, it doesn't. It is not a direct variation, so it is not direct. Okay. So since it's not direct, we can't write the function rule. Can't do anything. Oh, I forgot to add one thing. This, if you hear me say function rule, that's what that means. So you're just writing the equation. So that's what function rule means. Okay. So now we're going to start doing with the equations. They don't give you a table anymore, which is fine. So for the following, y varies directly with x. So y equals kx. It's that direct variation formula again. So the first step whenever you are doing this, solve for k is your first step every single time. So they give you these first two, and I'm going to plug those into that formula. So y equals k, oh sorry, not y. 9 is our y, equals k times negative 15. So you would divide both sides by negative 15, so y equals 9 over negative 15. Is that your answer? No way, Jose. We always have to reduce fractions if we can, and you get negative 3/5. Okay, so we've got step 1 done. We solve for k. Now, step 2 is plug in k and what they give you. And then step 3 is solve for what they say to solve for. So the next part of this is what is y. So we're solving for y when x equals 21. So we have our k, so we're still going to use y equals kx. So y, what is y? We don't know what y is. That's what we're trying to figure out. Equals k. We know our constant of variation, our k, is negative 3/5 times x, which is 21. And literally all you have to do is solve it. So y equals negative 63/5, or if you're a weirdo who likes decimals, what would that be? 12.6, negative 12.6. And that's it. So, okay, let's do another one. If you want to pause the video, you try it on your own, see if we can get the same answer. So first thing I'm going to do is solve for k. So y equals, sorry, I keep doing that. Y equals kx. So 15 equals k times 3. Solve for k. So k equals, geez, I'm struggling. K equals 5. Okay, so we got our k. Now we're going to plug it into what they tell us and solve for the whatever variable they tell us. In this case, it's y again. So y equals kx. So 5 times 12. Y equals 60. And that's it. It's really that easy. It's just kind of a weird thing that we're doing. It's not too bad. Okay, so now is the relationship between, or back to tables, is the relationship between the variables in each table a direct variation? So remember that looks like y equals kx. An inverse variation, which is y equals k divided by, I don't know why I put 6, x. Or neither. Okay, write equations to model the direct and inverse variations. So let's look. So let's see, and I'm going to change these to x and y because I don't want to mess with u and v. Okay, so do you see anything that's happening consistently to x that gives you y? What I see is it's being multiplied by 5 each time, right? And all of the times. So the function rule, which is what they want, or first of all, is this direct or inverse? It is direct. And let's write their function rule. It would be y equals 5x. Okay, and that's it. So for me, I see direct variation a lot easier. Sometimes I have to struggle a little bit to see inverse variation, which you're about to see what happens. So first thing I always go to is direct. 1 times what is 6? Well, that would be 6. Is 3 times 6 2? Nope, that's not going to work. Okay, so since direct variation doesn't look like it's going to work, let's try inverse variation. So remember, inverse is k divided by x. So is there a number divided by that x that gives you 6? So what divided by 1 gives you 6? Well, that would be 6, right? 6 divided by 1 is 6. Let's see if it works for the next one. 6 divided by 3 is 2. Perfect. We're doing good. 6 divided by 12, that's 1/2, which is 0.5. Good. 6 divided by 15 is, that would be 2/5, which turns into 0.4. So yes, that works. So this one is an inverse variation. And then they also want us to write the function rule. So that would be y equals, what is our k? In this point or instance, it is 6 over x. Okay, so we're getting close to being done. So I'm going to change these directions a little bit. Don't worry, I changed my mind. We're not graphing because you're not doing those on your quiz or your test. So suppose that x and y vary inversely. What does it mean to vary inversely? Well, that's y equals k over x. So write a function that models each inverse variation, and then we're not going to graph, so take that out. And then find y when x equals 10. So first thing we need to do is write a function. Okay, in order to do that, we need to solve for our k, always and forever, solve for k. So 11 equals k over x, which is 1. So what does k equal? K equals 11. Okay, so then let's go ahead and write our function rule. So y equals 11 over x. So there's one answer. That's our function rule. And then the next part of the directions want us to find y when x equals 10. So there's some problems like that in your homework. All you're doing is plugging in 10 for your x and solving it. So that would be 11 over 10, which you could leave it just like that, or you could say 1.1, right? Okay, letter B is too easy. Let's skip down to letter C. So letter C, first thing we need to do is solve for k, solve for k. So 3 equals k over x, so 1.2. You're going to multiply both sides by 1.2. So you have 3.6 equals k. Okay, perfect, we got the k. Now let's write our function rule. That would be y equals 3.6 over x. And the last thing they want us to do is plug in 10 for our x and solve. So 3.6 divided by 10 is 0.36. And that's it. One more with a good old-fashioned fraction. So -1/3 equals k over x, so 5. Okay, there are a few different ways to solve this. The way I see is to cross multiply, and don't forget about that negative. So I would have 3k equals, let's say -5. I'll throw the negative with the 1. Divide both sides by 3, so k equals -5/3. We got our k, so now let's write our formula. So it would be y equals, now watch this. So this would be -5/3 over x, okay? We don't really want to write it like that. So could I break this up into -5/3 times 1 over x? The answer is yes, you could. And that's what you see in the book they do. And so the actual function rule, how they want you to write it, is -5 over 3x. Okay, so that's one answer. Last one, let's plug in 10. So -5 over 3 times 10, which would be -5 over 30, which turns into -1/6. Okay. So I am going to add another equation or another problem because you have one like this on your quiz and test. So give me just a second. Actually, I'll just write it out with you on here watching, sorry. So the directions say, let's write this down because you'll need it. Find z when x equals 2 and y equals 4. Okay. And then the actual problem is z varies directly with x and inversely with y when x equals 6, y equals 3, and z equals, we'll say 12. I kind of made these numbers up, so hopefully they work out okay. Okay, so first we need to solve for k, but in order to do that, we have to set this up. So don't freak out, it's not that bad. Let's break it down piece by piece. What does it mean that z varies directly with x? Well, varies directly means it's z equals kx, right? And then what does it mean if it varies directly with x and inversely with y? So that would be divided by y. Okay, so if you notice, we have that set up, but if you go back to the very beginning, it looks just like what we had up here. So direct and inverse. That's why one of the reasons I didn't have you memorize that is because you can build it on your own. So, I mean, if you want to memorize it, you can, or you can just know how to put the two together, whichever you prefer. Okay, back to where we were. So we need to plug all this stuff in. So they give us all this, and we need to plug it in and solve for our k. So 12 equals k times x, which is 6, over y, which is 3. Okay, I don't know about you, but I'm going to simplify this up. So 12 equals 6 and 3 becomes 1 and 2. So 2 times k. Divide both sides by 2, so k equals 6. Good. So now they want us to find z when x equals 2 and y equals 4. So we know our k, we know x and y, we just have to plug it all in to find out what the z is. And you're plugging it back into the same joint and inverse formula. So z equals our k, 6, times x, which is 2, over 4. Hey, this actually works out to be a whole number. I did a good job making it up. So z equals, that would be 12 over 4, so z equals 3. And that is your answer. So you do have a couple like these that are a little bit different on your homework. There might even be some of the ones that are joint and stuff, so if you need to go back and look at those, what the formulas are, you definitely do so. I will tell you right now, you do have one just like this on your test and quiz. So you definitely need to be prepared for that. All right, that is it for this video. Thank you so much for watching. I hope you have a great rest of your day.